Hi there, this is Teacher Josie, and I'm here to graph linear inequalities into variables. I will guide you every step of the way, going at your own pace, and I will make it as lively as possible. So, stick with me and keep subscribing free educational videos from B1's Mathematics Department. Let's review graphing linear equation into variables. Remember, there are different methods in graphing linear equation into variables. One is using any 2 points. Another, the slope and y-intercept, and x and y intercepts. So let's graph x plus 2y is equal to 4. We will use the intercept method or the x and y intercepts. So let's find the x-intercept. We will let our y be equal to 0. So our x is 4. We plot 4, 0. Next, the y-intercept. So we will let our x be equal to 0. So our y is 2. Plot 2, 0, 2. Connect the 2 points. So this is the graph of x plus 2y is equal to 4. It is a straight line. All of the points on this line are the solutions of x plus 2y is equal to 4. Since negative 4, 4 is on this line, it is a solution. If we check, our x is negative 4, our y is 4. So negative 4 plus 8 is 4. It is true. And 6, negative 1. So if we substitute it here, our x is 6 and our y is negative 1. 2 times negative 1 is negative 2. So 6 plus negative 2 is 4. It is also true. So 6 negative 1 is also a solution. And as you can see, it is on this line. You have seen that the graph of linear equation in two variables is a straight line. Just like linear equation in two variables, linear inequality in two variables has infinite number of solutions. What about its graph? And how do we graph such mathematical sentence? The graph of a linear inequality in two variables is a set of all points in the coordinate plane whose ordered pairs satisfy the inequality. Unlike linear equalities whose graphs are represented by lines, linear inequalities have graphs represented by half-planes that contain the points that satisfy the inequality. In the cases of ax plus by is greater than or equal to c, and ax plus by is less than or equal to c, the graph of the inequalities includes the plane divider, or the line ax plus by is equal to c. When a line is drawn in the coordinate plane, it is divided into two regions called half-planes. The dividing line is called the plane divider. So this is the plane divider. It is either a dashed line or a solid line. It divides the coordinate plane into two regions called half-planes. To graph an inequality, replace the inequality symbol with an equal sign and plot points that satisfy the resulting linear equation. If the original inequality has the symbol is greater than or equal to, or is less than or equal to, draw a solid line. If the original symbols is greater than or is less than, draw a dashed line. The dashed line or broken line indicates that the coordinates of all points on the line are not part of the solution set of the inequality. The line drawn becomes the plane divider. Then, choose an ordered pair located on one half plane and test this ordered pair in the inequality. If the ordered pair satisfies the inequality, shade the region that contains it. If not, then shade the region on the other side of the plane divider. Let's have the examples. Number 1, graph y is greater than x plus 4. So we replace the inequality symbol to equal sign. We now have y is equal to x plus 4. So we find values of x and y that satisfy the equation. So when, let's say our x is 2, so when x is 2, our y is 6. When x is negative 2, negative 2 plus 4 is 2. So we will plot these 2 points, then connect the points using a dashed line. So we now have our coordinate plane. We plot 2, 6, then negative 2, 2. Again, we connect the 2 points using dashed line because of this symbol, meaning our boundary line is not included in the solution set. And for us to decide on what region to shade, we will have our test point. Let's say 3, 3. So substitute. So y is 3, x is 3, 3 plus 4 is 7. So is 3 greater than 7? Since we obtained a false statement, 3, 3 is not a solution of the given inequality. So we will shade this region. All of the points on this shaded region are included in the solution set. This is now the graph of y is greater than x plus 4. Number 2, y is greater than or equal to x plus 4. So the graph of the given linear inequality would look the same in number 1. The only difference is the plane divider. This time it is a solid line because of the inequality symbol is greater than or equal to. Meaning all of the points on this line or on the solid line are part of the solution set. So this is the graph of y is greater than or equal to x plus 4. Okay, let's have our example in our review. This time, since it is a linear inequality, so we change the symbol, the mathematical symbol to greater than or equal to. Again, our x-intercept is 4. So we have here 4, 0. Y-intercept is 2. So we have here the point 0, 2. We connect the 2 points using, correct, it is solid line. The boundary line or the plane divider is part of the solution. Now, for us to decide on what region to shade, let's have the test point. Let's say 0, 0. So we substitute. If x is 0 and y is 0, 2 times 0 is 0. So 0 plus 0 is 0. Is 0 greater than 4? Okay, so we obtained a false statement. 0, 0 is not a solution. So we will shade this region. So all of the points on the shaded region and all of the points on our boundary line are the solutions of x plus 2y is greater than or equal to 4. Let's say 3, 4. Since 3, 4 is on the shaded part, it is a solution. Also, 5, 3. Since it is on the shaded region, it is a solution. Also, 6, 5. 6, 5 is a solution of x plus 2y is greater than or equal to 4. What about 2, negative 2? Since it is not on the shaded part, 2, negative 2 is not a solution. To check, if you substitute it in the given inequality, the coordinates of the ordered pair 2, negative 2 on the inequality, we will obtain a false statement. Let's have the activity. So graph the following linear inequalities into variables. Let's check. So this is the correct graph in number 1. This is also the correct graph in number 2. I use the Desmos. Desmos is a free online graphing calculator. You can also use this to double check your answer when you are graphing. That's all for now. I hope that you enjoyed learning with me. If you did, hope to see thumbs up or a smiley from our chat box. See you on my next video.